Hey guys, Will Robinson here from Robinson's Auto, toolsandtime.com. Well, yesterday I get a phone call from a good customer of mine. And if you go back about 9 months ago, I made a video on how to troubleshoot and diagnose a bad starter. Well, Mike's on the phone and he says, "Hey Will, this is Mike. Ford Escort's not starting." I said, "Oh, get out of here. Don't tell me that new starter went bad already. What's going on?" He says, "Well, when I turn it to start, nothing happens. I don't hear any clicks. Headlights are on, they don't dim down." I'm thinking to myself, man, this starter's only 9 months old. It should have went over already. It only had a 3-month warranty on it. You know, it's remanufactured. But what can it possibly be? Is it the starter? You know, you have to ask yourself that question. So I tell him, all right, let's get it in the shop. If it is a starter, I'll make sure they do good by it, and we'll get you back on the road. So the car was towed in. I go out there. First thing I do, it's cold outside, so I grab myself a jumper. Pretty much a screwdriver or anything in that manner, and I pop the hood and make sure it's in neutral, got the emergency brake on, and I go in there and I jump the starter out. You know, you have your hot terminal, and then you have your other terminal that's only hot when you turn the key to start. So I unplugged it, and I jump it too. Starts. I'm like, what just happened? You know, evidently it's not the starter. There's something else going on. Well, that leads us to where I am right now in the diagnosis. I haven't went any further with my troubleshooting. I figured I'd take you guys in there with me, since we are doing this series on electrical troubleshooting using schematics. I thought, you know what, this would be a great way to show you how I go about troubleshooting a no-start electrical problem using a schematic. So let's get started. Still nothing. Okay, so let's start our troubleshooting. Like I showed you in previous videos, I always like to start at the source. In this case, the source will be the starter. So we go down here to the starter and we'll unplug that little terminal that's on the starter. Once you got that unplugged, I'm going to be doing this whole test. I'm going to try to do all this troubleshooting with nothing but a test light. As you can see, it's a simple test light, and we just confirm that it's good. So I'll be connecting that to the ground, so when I hit a positive connection, and if there's power, it'll illuminate the light bulb. So let's go down there and do some checks. Okay, I got you guys down there on the starter, and as you can see, I got the small terminal unplugged. As you can see, I got the small terminal unplugged. That would usually plug into your starter solenoid right here. This terminal here is your main hot. We know that's good. It illuminates the light bulb. So at the source here, if this circuit is complete, I should be able to probe it like so. So if I go in there When I push in the clutch and turn the key to start, the ignition to start, that light bulb should light if this circuit is complete. Okay, you guys watch it. I'm going to go try it. Okay, ready? Keys on. Clutch is pushed in. Start. Do I have anything? There it is one more time. Start. Is there anything out there? Okay, here we are at the wiring schematic. Let's come down here for a minute to the starter assembly. As you can see it illustrated here in its entirety. If you go back to chapter 1, you know a component is shown in its entirety when it's illustrated with a solid box. Let's go back to our initial test. Remember that big lug on the starter solenoid? Well, that's this conductor right here. It comes directly from the battery, and we confirmed that this is good with the test light when the bulb lit. Then I proceeded on to the control side of the solenoid. We confirmed that we do not have voltage present on the control side of the solenoid. So where would I go from there? Well, I would back up. And if you come back to the beginning of the circuit, it comes directly from the battery to a main fuse. It's a 100 amp fuse. We're working on a 1.9 liter engine. If this fuse is good, it comes up here and we should have voltage present at the ignition switch. And I can see here that this same conductor controls. It actually tees off here and comes back as another conductor, but we'll get to that later. We're working on the start system. However, it all shares the same power source. Therefore, I ruled out this fuse as a possible cause because I do have accessories and the vehicle does run. So I know that this fuse is good. So from there, I would come down, and as long as these contacts are good, I should have voltage present at this clutch safety switch. I'm going to jump past the ignition switch because that's harder to access than this clutch safety switch. This clutch safety switch is a device that's built into the circuit to prevent the operator, the driver, from starting the vehicle with the vehicle in gear. Therefore, you need to press the clutch in for these contacts to close in order for your voltage to be present on your control side of your starter solenoid. Okay, so let's back up. Let's not get too far ahead of ourselves. So the next component I want to test would be this clutch safety switch. So I'm going to go in the vehicle and see if I do have voltage present at this switch with the ignition in the start position. And that will tell me if this ignition switch is good or if we have another problem and it may be this clutch switch. So let's back up and see if we have voltage present at this switch. That would be my next test. So let's go see if the contacts are good in that safety switch. We take and we follow the clutch pedal up. You see a couple switches there. Oh, the safety switch on this one is actually a plug that's up a little high. And that's this switch in the back. I don't know if you can see it from there. It's just a normally open switch, and when you push the contact in, it closes and completes the circuit. So I got the harness pulled down. Let's unplug it. Actually, you know what? Let's use a multimeter to do a continuity check on this switch. And that'll eliminate it altogether. Let me go get my meter. Okay, I got my meter. I got my DVOM. I got it set to continuity. We don't need to look at the meter, remember, because as long as it's under 120 ohms or so, you should hear the audible signal. And just for an example, I'll take in, as you can hear the signal. So let's take the harness on the switch end, on the safety switch end, hook it up, I'm going to be using my alligator clips. Okay, so I got that hooked up. So when I push this clutch in, if that switch is good, we should hear that audible signal. And as you can see and hear, that switch is working fine. So we can eliminate that switch as the problem. Okay, so where do we go next? Okay, let's look at the schematic again. We just confirmed that this switch is good by doing a continuity check. So what I would do now is back up to this ignition switch. Simply, I would check this black dark blue wire on the control side, the harness side, coming down from the ignition switch to this clutch switch, and see if I have power when I put the ignition in the start position. And that will tell me if these contacts in this switch are good. So let's go back and do that check. So the next process, what I'm going to do is go to the harness side, this connector right here. We'll be using the test light. And what I like to do, hook my test light to ground, but to make sure I have a good connection, I usually go to like the fuse box, find a fuse. That's good. And as you can see, I know my ground's good on the ground side of my test light. Therefore, I can take an accurate test. I can perform an accurate test on the harness side of this connector, of the safety switch. Now, we know by looking at the schematic, take and fold this over, you see we have two wires. This one's black with a blue tracer, that one's red with the red tracer, or this one's black with a blue tracer, and this one here is black with a red tracer. The black with the blue tracer comes directly from the ignition switch. It'll go down through the safety switch, back around to the black with red tracer, and out to the engine compartment. So let's see, when I put the ignition switch to start position, I should have power on this black with blue tracer. Let's try it. So I got her probed. Keys in the on position. Start. Nothing. So I have no power coming down from the ignition switch. So where do we go from there? Let's go look at the schematic. Alright, we just confirmed we do not have voltage present at this connector coming directly from our ignition switch, start contacts, to the clutch switch. We do not have voltage present. So now we need to back up, remove the covers on the steering column, and check the ignition switch itself. Okay, I'm going to simply unplug these connections by pressing in that tab, pulling out. I'm going to do the same thing with the top one. Okay, now let's do a continuity check on our ignition switch. We can simply check these by doing a continuity check. Let me show you from a troubleshooting chart. Okay, here I brought up the test procedures for the ignition switch. Alright, 1. Test for continuity between specified terminals with switch in each position. See Figure 2. I got Figure 2 up over here to the right. If continuity is not as specified or is poor in any switch position, replace ignition switch. Okay, step 2. Continuity should exist between terminals B1 and ST with the switch in start position. Continuity should not exist with switch in any other position. Okay, this is the test that we want. So B1 and ST. So we come over here to the pinout and we want B1, which is right here, and ST. We want to perform a continuity check between these two terminals. I should only have continuity with the ignition switch in start and no other position. I have a feeling we don't have continuity in the start position. So let's perform that test. Okay, from looking at the pinout on the schematic, we know we should have continuity in start from B1 to the start terminal. So since this is upside down, it should be B1 will be this lower terminal, and the start terminal will be the lower right on this side, on the right side. Okay, let me get my alligator clips and then set my multimeter and set the DVOM to continuity, and let's check this switch. Okay, I got my DVOM leads. I got the meter set to continuity. We can double check it by touching these two leads and listening for that audible signal. So if my contacts have less than 120 ohms resistance, when I put the ignition switch to start, and I have it on the start terminals and B1, we should hear that audible signal. Sometimes it's easier said than done. Okay, we have that set up. Got the alligator clips hooked up to B1 and the start terminal according to the schematic pinout. Let's put the key in the ignition. Turn it to start. As you see, I have no continuity going through them contacts. Alright, let's pull that ignition switch off and take it apart and see what's happening. Okay, now I have the switch over here at the bench. I know you really can't see it that good here because my lighting's not that great, but if you look in there now, you can read the terminals. It's stamped in the plastic. So B1 is this lower terminal, and ST is your start terminal, the two terminals that we did the continuity check on and determined we had no closed circuit when we put the ignition switch to start. So let's disassemble this switch and see what we can find. Okay. They don't really make these things to come apart too easy. Okay. So we've got the outer cover removed. You can see in here it's just a series of ramps. They can push these terminals down to each other. Let me get you another light. Let's look at this side of the switch housing. This is the side that simply the mechanism from the lock cylinder goes in and you turn it to whatever position. Now if we look on the back side of this, you can see what takes place here. There's ramps per se that are laid out in a manner that if you come over here, this is the new switch, where's the old? If you come over here, you'll see there's a row of little white tabs that are spring-loaded. That simply, I'm assuming on the other side, are the contacts that push down on the contacts and complete the circuit. What I noticed here right off the bat was, see how high these tabs are? Look how low that tab is. It's worn down. And the same thing with these plastic pieces in here. There's grooves worn into them. So over the years, the plastic part of the switch is simply deteriorating, wearing down. So let's open up this and see what's underneath there. We know it's this one right here that's worn down the most. Let's see if that's our start contact. Wow, I bet it is. And if you look here, it's melted into the contact. The contacts are alright, but this contact simply got so hot that it melted that little tab into it. Now this could have happened, this could have started happening from the old starter. There's a very good chance that when that old starter went bad, this started getting hot and actually melted down into the contact. Or if you had a low battery, say if you had a low battery and he's trying to crank it, you create a lot of heat. And since there isn't a relay, you have these heavy contacts in this ignition switch, which means you also see the heavy gauge wire running all the way back to the ignition switch. We'll get to that later. But there's going to be a lot of heat generated here if you have too much current draw. So somewhere along the line there was too much current creating heat at this contact, which melted that terminal down. So let's switch back over. In return, what made it so short that it no longer would ramp up the way it should on this portion of the switch. So let's see if that is the case. I'm pretty sure it is. This is B1. So we take our one alligator clip from our DVOM. I still have it set on continuity, so if I touch them together, you'll hear the audible signal. And then we'll go to the start contact. Oop. So when this portion would go to the start, it would simply it would ramp off one of these ramps, whatever one might be for that one, and simply close those contacts. So we know there's nothing wrong with the contacts in this switch. It's simply this plastic melted down on that contact and wouldn't let it connect, which is probably a good thing, because if that plastic wouldn't have melted underneath that contact, this starter would have kept on cranking even with the switch off. So it's actually a good thing that plastic melted down the way it did. So if I took and cleaned that plastic out from underneath that, for example, let me disconnect this for a minute and try to clean that out. Let's see if I'm right. Put it back together. As you can see, that would have allowed that circuit to be complete even with the switch off and keep cranking. So it's a good thing that plastic melted in the manner that it did. Here's the new ignition switch. Just for giggles, I'll check it. This one doesn't have a pinout on it, but we know it's that terminal and this terminal for the start. And when I go to start, I have continuity, so we know that's good. So we're good. Okay, since we know those contacts are good, let's go put it in the car. Okay, now we can plug the electrical connections back in. Hear that click? There you go. So we go out and hook the battery back up. Alright, as you can tell, I got the battery hooked back up with this annoying door beeper. I'll push that in for now. Let's see if it starts. See if we took care of the issue before we go putting all the covers back on. Install the tape. Looks like I have all my accessories. The radio came on. So everything's lit up. Looks good. When I hit start without pushing the clutch in, it doesn't try to crank. I got everything plugged back in. I got the starter control wire plugged back in. I got the safety switch plugged back in. So when I push down on this clutch, it should start, as long as we fix the problem. Let's try it. There it is, guys. Looks like we got it. Try it a couple times. Awesome. Okay. Okay, so I guess that's going to wrap it up for us today. And that's how you go about troubleshooting using a schematic. You just follow it back and it led us right to the issue. I'm going to keep on going more in this series and, get into more detailed things. I figured this would be a perfect example of troubleshooting using schematics, so I figured I'd throw it up there, and I took you step by step. I didn't troubleshoot this prior to making this video. And that's an honest statement. I went as far as jumping that starter out, and you guys tagged along the rest of the way. So that's how I do it, man. Well, I hope you enjoyed. You can always come visit me at toolsandtime.com. Stop by the helpful forum. I find it easier for me to answer questions at the forum. I could type a longer paragraph without running out of characters and all the other stuff that you might run into on YouTube. But however, if you still want to leave a comment on YouTube or ask questions, feel free. It's fine. That works just fine. But you might get a quicker response if you come visit me at the toolsandtime.com forum. Also on the toolsandtime.com website, you'll find all my videos in a nice user-friendly category. I call it my virtual repair shop, and you'll see why if you stop by. I put a lot of time and effort into that site for you guys, and I hope you enjoy it. So that's going to wrap it up for today, or for today I should say. It's going on 2:30. It's New Year's Eve. Happy New Year's, guys. I just want to take a minute to give a shout out to my friend Dwayne over at realfixesrealfast.com. This guy's a phenomenal teacher. I learned from watching his videos, and that's the honest truth. He's an inspiration to me, and I'm not ashamed to admit it. This guy's above me, above my level of production and troubleshooting and teaching, to say the least. Phenomenal guy. And I encourage you guys to go over, check out his videos. He has a YouTube channel as well, Real Fixes Real Fast, and also realfixesrealfast.com. And I encourage you guys to check that out. Alright guys, have a good one. Be safe, and have a happy new year. See you next year.